21. 21. What age was the oldest actress?
80.
80. What age range contained the most actresses?
30s.
In their 30s. I mean, I could have even said, let me throw another one in there. What if I said part D? How many people were in their 60s? We would go to the 60s, and this would be 60. I'm going to write them out just so you can see it. 60, 61, 61, 61, 62, and 63. So technically, you're just counting these. 60, 61, 61, 61, 62, 63. So 6 people were in their 60s. Cool? You're going to have one of those. Even though I did 4, you're only going to have 1. Now, this one kicked your booty on the test when y'all took it. Use a histogram to answer a question. Remember that a histogram is when you have bars that touch. So this one went from 50 to 59, which means this one starts at 60. So the reason they touch is because they're back to back on here. Now, I put my answer choices off to the side. These are my answer choices. Some of y'all are going to say, thank the Lord, I can eeny, meeny, miny, moe it. The histogram above shows relative frequencies of scores on a math compatibility test. If 1,200 students took the test, how many students had a compatibility between 80 and 89? So 80 and 89, do you agree we're talking about this bar? So if we come over, okay, now look at my answer choices. Do any of my answer choices match me coming over? No. So, and on your test, y'all, it's going to be on the computer. So some of y'all, when you bring your finger over, you kind of go up or you kind of go down without realizing it. So if it was me, I would take my scratch sheet of paper and put the edge of it against the computer monitor. So I know that it's perpendicular, it's flat. That way I can come over and measure completely. Okay? So you don't want to do it like that. So I always say put it against the monitor or against the bottom, and then that way you can come across. So what number does this represent if y'all had to give a guess?
0.7.
Okay? 0.07, 0.06, point something in that general area. 0.065, somewhere around there. Now, how am I going to get my answer? Besides, always pick C. What do you think I'm going to do?
Subtract.
Have 4 choices: add, subtract, multiply, divide. Anybody remember? How many total people did we survey?
1,200.
1,200 people took the survey. We cool? And we want to know just about this bar. Well, this bar is called relative frequency. Relative frequency, back in the day when we did, I'll do it over here because I'm recording. Back in the day when we did red, blue, green, and we said, and that was our category, and this was our frequency, and we said 4 people like red, 1 person likes blue, 5 people like green, remember that? And then we did relative frequency. Remember those? Relative frequency is when we said 4 people out of 10, because 10 people were asked, 4 people out of 10 like red. We can either write it as a fraction, we can write it as a decimal, or we can write it as a percent. Remember that? So we can write this as 2/5, we can write it as 0.4, or we can write it as 40%. So relative frequency can be a fraction, a decimal, or a percent. In this case, I gave it to you as a decimal. Now, if it was a percent, what would the percentage be? 7% due to whoop-whoop. So, do you agree that 7% of the entire group scored in the 80s. So listen to what I just said. 7% of the total scored in the 80s. I can do it in one or two ways now. I can do it as an is over of equals percent over 100, or I can do it as the shortcut. The is over of, where does the 7 go in the is over of? Above the 100 because 7 is a percent. Where does the 1200 go? At the bottom because that's your total or your of. And we're trying to find the is. Now if I do the shortcut is 7% of 1200. What does of mean in mathematics? Multiply. And what do we have to do to a decimal before we can use it mathematically? Whoop, 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 whoop. So that's going to be 0.07. So I can do it one of two ways. I didn't open my calculator. Let me get this open and then we will look at it. So I can either do 0.07 times 1200, or I can do 1200 times 7 divided by 100. They're both the same thing. They're going to give me the same answer. So just to show you, so for the first way, if I do 1200 times 7 divided by 100 is 84. The second way is going to be 0.07 times 1200, which is 84. Now, I go to my little answer choices. Do you agree that 84 is not my answer choice? I have nowhere to put this. I'll put it down here. But do you agree that there's only one that's in the vicinity? 96. So I go back and I say, well, maybe I didn't come over straight enough. Maybe it was 0.08. So, I mean, I could go back to my calculator if it makes me feel better and do 0.08 times 1200. You with me? But there's only one that's even close to that answer. We good? Who's not liking that one?
It was fine.
All right. Interpret a stacked line chart. This is where we put them on top of each other. So remember, this is just the men, this is just the women, this is total. So the question says, estimate the number of bachelor's degrees awarded to women in 1990. So the first thing we're going to do is we're going to go to the women and we're going to go to 1990. So technically, I'm looking at from here to here only. I cannot come straight over. Because, y'all, I put that answer there because a lot of people will come straight over. But remember, that answer represents the men and the women. I just want this. Now, the good news is, on your exam, I did like that, and I put the boxes so you can count the boxes. Remember doing that? These aren't the right boxes, but just pretend. See how I have one whole box, and a part of a box? So this would be like 200 and some change. But for this problem, I didn't have boxes, but can you see that I'm going from about 500,000 to a million? So I would do 1,000,000 minus 500,000. So which of my answers do we think it's going to be?
B.
Hold on, let me draw my boxes because some of us aren't seeing it. So if we have a box at 500,000 and this is at 1,000,000, do you agree we're going to have a 6, 7, 8, and 9? So if I come across, and then I'm going to do like that. So can we see that I have a full box, a full box, a full box, a full box, and I have a partial box here and a partial box there. So what are we thinking? How many full boxes did I have?
457.
1, 2, 3, 4 full boxes. I would probably say 457 is what I would say. But yours are good. I'm gonna do one later in the class. Mine have thick lines and everything, but y'all with me? All right, let's do another one. Determine the median. Remember, if you're drunk, the median's in the middle of the road. The DUI cop tells you to walk the median. You can only have one median in the middle of the road. You can either do this old school, or you can do this new school. Old school would be to put them in order and find the one in the middle. So old school, put them in order, and if there's two numbers in the middle, what do we do? Add them up and divide by 2. New school is when I did, and you can do it both ways to check it. New school is when I do stat edit. I go to the top, clear it out. I type in my data. Type in my data, then I'm going to work it out, stat calc. I only have 2 choices. I have one variable statistics and I have linear regression. We only have one set of data, so it's going to be one variable statistics. So one var stats. There's my first page of data. My error tells me to go down to the second page of data. We are looking for the median, which is going to be, I didn't type my numbers in right. Go figure, I never type my numbers in right. So here's my L1, I did stat edit, then I did stat count linear regression. This is my first page, this is my second page. The only thing that I want for this problem is the median. My median is 52. Here is old school. I put them in order from least to greatest. I found the one in the middle. If there's 2 in the middle, you add them up and divide by 2. Yay? All right, weighted mean. Y'all, you actually did this just a minute ago, the very beginning of class, when I said your average counts 80%, your exam counts 20%. We were doing weighted average. So this is the same exact thing. This one says your midterm is 15%, and you made a 75 on your midterm. Your project's 20%, you made a 90 on your project. Your homework is 40%, you made an 85. Your final is 25%, you made a 72. So we are going to multiply the percentage after we whoop it times the grade. So I made a 75 and it counted 15%. So 75 times 0.15, or you can reverse it, 0.15 times 75, doesn't matter. Then 20% times the grade, 40% times the grade, and 25% times the grade. And I typed it all into my calculator, and that told me what my final grade was. All right. Number 15. Identify the distribution as symmetric, left skewed, or right skewed. You only have one. I gave you several. Symmetric is that bell-shaped curve. Left skewed is when I'm pulling the rope from the left-hand side. Right skewed is when I'm pulling the rope from the right-hand side. So we really want to know where's my outliers. If my outliers are on the left, it's left skewed. If my outliers are on the right, it's right skewed. If I can have outliers on both ends, then it's going to be symmetric. The annual incomes of all stats class, including the teacher. So if we have from 0 to a little, because the teacher doesn't make too much, most people in a stats class are students. A lot of students either don't work or have part-time jobs. So most of the students are going to be somewhere here. The teacher is probably going to make just a little bit more than y'all. So is this left skewed, right skewed, or symmetric? This one's going to be right skewed. Because you can't go past 0 because it's your income. It's not how much you owe. You can't have an outlier over here because you can't make a negative amount in salary. Reaction times of 500 people. So if I get in a car with you and I say, drop, stop, roll, whatever, I don't know how long it's going to take the average person, but most people will react in the same. Is there going to be somebody that will react slow? Yeah. Mary, oh, you want me to stop? Really? Is there somebody that's going to react fast? You know, this minute you make a twitch, they're slamming on brakes. So we have outliers at both ends, so this one's gonna be symmetric. Now, on your exam, for number 21, I have some people that'll go from 0 to 100 and some people that will go from 100 to 0. So on your exam, if I give you one like this, I'm gonna say put 0 at the left and 100 at the right so that we're all using the same scale. So I may say age 0 is on the left, age 100 is on the right, just so that we're all using the same. So if I draw this, newborns to 100 years old. People with dementia are usually where?
Older.
They're usually older. Can I have somebody young that has memory problems?
Yes.
Yes. Can I have somebody in the 150s that has? No, I can't have too much of an outlier on that end because you can only be so old. So what skewage is this one?
Right. I mean, like.
Yeah, left. My bad, I didn't know my left from my right for a minute. You only have one of those, but I did a couple for you to look at. Standard deviation. Standard deviation, how do we find the standard deviation?
Punch it in your calculator.
Punch it in your calculator, what are we looking for?
1 bar stat, SX.
1 bar stats and the SX. Standard deviation is your SX. So for this one, we do stat edit, type it in, stat count, 1 bar stats. We're looking for the SX. She told me verbatim what I needed to do. Okay? I'm looking for the SX. That's my standard deviation. SX, my 6. Now, the next question says, obtain the 5-number summary. It's the same thing. You punch it in your calculator, you 1 bar stats it, but you go to the second page, your second page, and there's your 5-number summary. The last 5 things on the second page of 1 bar stats. Those are your 5-number summaries. 34, 39, 52, 63, 79. And remember, it's multiple choice. They may all start with 34. They may all have a mean of 52, but you've got to make sure you pick the one that has everything correct. So both of those problems have the same steps. You're just looking for something different.
Wasn't there a standard deviation where we had to guess?
No.
There's none on this test? Okay.
She was asking about that range rule of thumb where you had to subtract and divide by 4. There's none on the exam.
Okay.
Yeah, if I don't do it on here, it ain't on the exam.
Okay.
Which grab, y'all? If you miss this stinking question, you better fail the class. Which one appears to be the most normal?
Big.
Normal curve, symmetric curve. I mean, we've spent months talking about normal curves. All right, so that takes us to we're in chapter 5 now. Y'all, this is what we did most recently. The next one is the 68, 95, 99, 7 rule. And on your formula sheet, it does remind you that 68% of the data are 1 jump to the left and to the right. 95% of the data are 2 jumps, and 99, are 3 jumps to the left and to the right. So that is on the formula sheet. This is the one where we said, is it a half jump, is it a whole jump? Remember those? I left it all on here, but let me show you. Let me get to my problem. The problem says we have a normal distribution with a mean of 50, a standard deviation of 10. Okay, so for these, we're going to go plus 10, plus 10, plus 10. Minus 10, minus 10, minus 10. Now, my first problem says greater than 40. So greater than 40 is going to be all of this. Go with me?
Mm-hmm.
Greater than 40 is all of this. Well, because this is symmetric, what do we know about this part?
50.
That's 50%, because the whole thing's 100%. What do we know about this little piece?
68 divided by
That's
2.
a 1 jumper. but it's not a whole one jumper, it's a half of a one jumper. So that's a 64 cut in half. So it's gonna be a 32 plus a 50, which is an 82%.
It's a 68 cut in half, right?
Yeah,
Okay,
yeah,
thank you.
my bad. Sorry. All right, now, the good news about this, and I have it written down pretty below. The good news about this, between 40 and 70, let me do that one before I move it down. Between 40 and 70, so we have a normal distribution with a mean of 50, a standard deviation of 10. So this is gonna be 40, 50, 60, 70. So I am one jump to the left, which is a 68 cut in half. Y'all with me? I am two jumps to the right, which is a what?
95.
95 cut in half. So it's going to be a 34 plus a 47.5. Y'all with me? The good news, on your homework, you had to know how to do that. But on your test, watch this. Percentage greater than 40. We draw it. If we know how to do the 68, 95, 50% plus half of a 68, we get 84. But y'all, we can do the normal CDF. Normal CDF says that the left is what?
40.
The right is,
999.
the mean is,
50.
the standard deviation is,
10.
that's going to give me 84.13. This is going to give me 84. There's only one answer that's close to that. Your normal CDF gives you a more exact answer. The 68, 95, 99, 7 will gives you an approximation. So you can use the exact answer to get the approximation. Y'all with me? So for this one, between 40 and 70, if I do the normal CDF, what is my left?
40.
My right?
70.
My mean?
50.
My standard deviation?
10.
When I type that in there and do my normal CDF, and I whoop it, I get 81.8. Well, 81.8 is not going to be an answer, but 81.5 is. Cool?
Mm-hmm.
Z-score. Okay, back to the formula sheet. Let me see, number 20. Oops, I got 19 here, but it's close enough. So we've done absolute error, we've done relative error, and now we're doing z-score. What does z-score represent? How many jumps? How many jumps my point is from the mean? How many jumps my point is from the mean? So the formula says data minus mean over standard deviation. So if I come back out here, the question says, given a mean of 22 and a standard deviation of 2.5, your data point is 19. So I want to know how many 2.5 jumps it's going to take me to get from here to here. Y'all with me? Now, is this way? What kind of jumps are this way?
Negative.
Negative. So if I have answer choices, I know it's going to be the negative one. Y'all with me? Now, if I use my formula, what is my data? 19, what is my mean?
22.
22, what is my standard deviation? So if I do data minus mean over standard deviation, I go to my calculator, data minus mean, and then I divide it by standard deviation. It's negative 1.5 jumps. We knew that it was going to be negative something because it was to the left. So we can narrow down my answer choices that way. Yay? All right. This one is what we just did in the past week or so. This is still chapter 5. You have a normal distribution with a mean of 100, a standard deviation of 16. You have 64 in a group. So this is group data. Tell me, what is the mean?
100.
So if it's individual or if it's in a group, do you agree the mean does not change? So my mean is still 100. What is the standard deviation of the group?
16 divided by the square root of 64.
Oh, love you. The new deviation is the old deviation divided by the square root of the size of the group. Y'all, this is going to be one of the easiest questions on the test, but y'all are going to miss it because it looks so super hard. They don't want no percentage. They don't want you to do, to the left and to the right and normal CDF. They just say, if I was a size 16 individually, what size am I if there's 64 people in the group? Look, determine the standard deviation. Figure out how big it's going to be if we have a group of people. That's all they want to know. They want you to redo the standard deviation. So the old deviation was 16. I have 64 people in the group. And you're going to ask yourself on the test, there's got to be more than that. This question looks really hard. There's got to be more than that. The question just says, what is the new standard deviation if I put a bunch of people in there? Put that in there for me. Size 2, 64 people's in my picture. Number 22, use the central limit theorem to determine a percentage. We have a normal distribution. Our mean is 6. Our standard deviation is 1. We have a group of 100 people, and my data is 6.2 or less. And it wants us to do a percentage. So, normal CDF, what is my left?
Negative 9.
Negative 999. What is my right?
6.2.
6.2. What is my mean?
6.
6. What is my standard deviation?
1 divided by the square root of 100.
1 divided by the square root of 100. Because I have a group, I have to redo my standard deviation. So, I come down here. Because it's a group, I had to redo my standard deviation. Now, all of your answers are either going to be in decimal form or all of your answers are going to be in percent form. So that tells you, a lot of y'all on your last test, you didn't make what you thought you made because you whoop-whooped it and you weren't supposed to whoop-whoop it and they asked for a percentage and well, you gave them decimal or vice versa. So the good news on this is they're either all going to be decimal or they're all going to be percent. Yay? All right, now let me save this for just a second. That was it for this time, but I want to start next time only because I've got a lot of pages on next time. So I want to make sure that I get through everything. So we did 22 problems of the 33, but we have a little bit left. All right, this one, probability. If 2 balanced dice are rolled, these are the outcome. And y'all, I gave this on the test. How many are there? 36. Because remember, we have a die. We have a die and a die. How many are on the first die?
6.
How many are on the next die?
6.
And 6 times 6 is 36. So this represents the 36 outcomes. Now, it says, what is the probability? Probability means what makes me happy over total. So my total is how many total do I have is going to be 36. Now, what makes me happy?
10.
Sum is greater than 10. So sum means we're going to add. And I want my answer when I'm adding to be greater than 10. And we've done so many of these, we know it's on a diagonal. These add to 2, these add to 3, these add to 4, these add to 5. So if I come down here, this adds to 12, this adds to 11, this adds to 10. You with me? We want greater than 10.
3.
So it's just going to be 3 out of 36. It didn't say 10 or greater. It just said greater than. So you don't want the tens. So my answer is either gonna be 1/12, or it's going to be 1/12. So all of your answers are either gonna be the decimal form, the percent form, or the fraction form. Cool? All right, let's look at another one. Oh, some of y'all got this on test wrong. Not. I do not want to major in math. Not.